Well, hello and welcome to today's lesson. We're going to be talking about 8.3 and looking at weak acids and bases. And so, again, just a quick reminder that you had strong acids that you were to memorize on there. So we do have these 6 that we look at. And the other thing is to remember that your acids that are strong 100% or completely ionize. Okay, and that's going to be the biggest difference between our strong and our weak. Our weak only partially ionize. So what's meant by that is if we are looking at our acid, when that acid breaks down into its ions, then since it completely 100% ionizes, then whatever the molarity of my reactants here is will also be my molarity of my products. Okay, that is not true for weak acids or weak bases. So let's just look at what we have here. So again, continue to memorize your 6. So to be sure that you memorize those 6. And then the key is that if it's not one of the 6, then all the others are weak acids. So with every problem you start, especially when we start mixing these together, you've always got to say to yourself, is it a strong acid or is it a weak acid? So weak acids, again, will only dissolve in water in small amounts, so they're only going to have a small amount of them ionize in there. And then again, when you're looking at your equation, this is again how it is normally written. So you've got your acid put into water, it will form your hydroxide ion, and then again your whatever your acid is, that ion. Again, we say that they partially, spelt wrong, ionize are partially soluble. So only a fraction of those ionize. We are going to have an equilibrium constant that we're going to work with. And so we do have a couple of things. Again, we have Ka, which is your equilibrium constant for acids. You're going to have a Kb, which will be your equilibrium for bases. And then when we have the pKa, then again, that is your pH for your acid. So again, going back to your weak acids, your pKa for acids, the smaller the Ka, the larger the pKa. And I don't have here, but the larger the Ka, the more acidic your acid is. Okay, let's see what else we need to talk about. Weak bases, again, so let's go back to your strong bases. Your strong bases, again, are those ones that were in group 1 and group 2. Not all of them, but most of the ones that are found there. Again, you're going to have a Kb, is what we're going to call your equilibrium constant for bases. You're also going to have your formula will kind of look like this. You're going to have your base plus water. Again, will form your conjugate acid and your conjugate base on there. And then on here, again, if your constant are small, your pKb, where am I getting it, is going to be large. Okay, so be sure you note that. I want to mention one more thing just real quick, because if you have a strong base or a strong acid, then your arrow here will be just a single arrow, because it is going to completion. It's not going to be reversible at all. Everything is going to 100% ionize, so it's going to be just a single arrow. The same thing for your weak bases or your strong bases. It would just be a single. If it is a weak, then because it's only partially ionizing, then it is reversible, it can go back and forth. Okay? So again, just some notation there. Then when we get to doing, again, the same formulas that I showed you earlier, what's going to make these more difficult? Not difficult, but more than what the Strongs were. Remember, since the Strongs completely ionized, again, I told you we could just use that molarity, so we didn't have to go back in and compute a molarity. With these, we are. So we're going to go using our rice table or our ice tables again, because we're going to have to compute molarities. So you're going to see that we are going to use our K equations again. So your Ka, again, will be for your acids, and it is products over reactants. Remember, again, you cannot use solids or liquids, so only your aqueous and your gases. And what you're going to find, and as I show you examples here, your hydronium ion and your acid ion, your conjugate base is what it would be, are actually going to be the same thing, because that comes back to where we minus X, on both of them, and it's going to be always a 1-to-1. So you can shorten this down, that it's actually going to be your hydronium ion squared. And again, I'm going to show you what we mean by that. And you may or may not want to do the shortcut. That'll be up to you. The other thing that we're going to talk about is percent ionization. This video probably, the first one won't talk about that, but it is going to be your hydronium ion concentration over your initial acid concentration. And for a base, it's going to be your hydroxide ion concentration over your initial concentration for your hydroxide. Okay? And I did put on there, I don't believe those are on your AP sheet, so I would check. We've got a lot of formulas that we've looked at. Check to see which ones are on your sheet. Check to see which ones are not on your sheet. Okay, let's add in just real quick. Let's see, was it something here? No. Let's go on again to your formulas. So again, here is a list of the formulas. Again, double check those against your sheet to find out which ones are and which ones are not, because I do know some of them are, but not all of them. So add in just an extra one here. Your KW, remember your KW was from last chapter, in which you had your pH plus your POH was equal to 14, and we knew that our KW at 25 degrees was 1.0 times 10 to the negative 14. So we're still talking about that same KW, except now it is the equilibrium concentration of your acid times the equilibrium concentration of your base. Okay, then there's a couple extras over here. We're going to start doing pKH, Ka, pKb, just like what we do pH and POH. Okay, so I'm going to stop there with this video, and then I'm going to do the examples on the next video.